The task number 7 here. What we are doing here is we are doing the two-dimensional function. So what you need before beginning is you need to import the NumPy and you need to import the matplotlib. So to define a two-dimensional function is the same idea as you define a function. So the function that we use for the example today is a sinusoidal function. So which might be the solutions from the wave equation or the solutions from the Schrodinger equations. Okay, so we begin with using the def again to define. So I will call my function as f sign. So the arguments will be the x, y. So these two will be the variables, and then we are going to add another two parameters, m and n. Okay, so here you can visit some website or some textbook for the solutions of Schrodinger equation with rectangular boundary conditions. Okay, so here I will just try to write a function for you here. So we begin with some kind of sine. Okay, so we are going to do sine m pi x over L basically, and times by sine the n pi y over L basically. But we want to simplify this function for you, so I will do m times the np dot pi and times by x, and then times by the numpy sine and n times np dot pi times y. Okay, and we are going to return the value of stat here. Okay, and then we will define the domain of the x and y by the command a range again. So I will call my array my x domain as the x data, and I will use the a range to create a range for me. So I will specify the values from -1 to n with the plus 1.01, and for each step we increase the values by 0.01. Okay, so this is gonna give you an array of number like this. So it start from -1. Yeah, this is the -1, and it ends with +1. Okay, and for the y data, we're gonna do the same here. Okay, just change this to y data. So basically we are going to have a square boundary for our function, and then I am going to introduce you to another command that is very useful, which is len. So len, it will give you the length or the size of an array. So if I basically type len x data, it will tell me like how many members or how many numbers are there in the arrays called x data. So if I do the len y data, you should just get the same number because it's the similar array. So, but here I will just throw this number of data into a variable. Okay, so I will define the nx equals to len x data, and I will define the ny as len y data. Okay, and then after that we are going to assign the values from this function to the array. Okay, so actually there are many ways to do this, but we start with this easiest way, but it might be the slowest way if you work with the big data. But if your data is not very big, that's no problem. Okay, so we are going to use the for loop here. So we get this integer, the length of the data, because we are going to use that in the for loop. Okay, so in this way, if I say that nx is the length of the x data, yeah, and so the range of the number zeros to nx, it will just give you the numbers start from 0 and stop with 200. And then I will do another for loop within this for loop. So I will do the for j in range 0 ny. Okay. So so this means that we are doing everything for each value of x and for each value of y. And what we do is to assign the values into an array. Okay, so firstly, we want to define an empty array. Okay, so my technique is to call the array as the z data. Okay? So for the z data, I will use the command called zeros. Okay, and in these zeros, I will input the argument nx and ny into a tuple. So running the z data here, it will give you the two-dimensional arrays that containing all the zeros. Okay, so you can imagine that it is an nx times ny matrix of zeros. Okay, now in this loop, for I in range and for j in range, we are going to change the values here, change from zeros into the values that we get from this function. Okay, so I will say that it is the exact data I j. Okay, equals f sign x data I and x data j, and then the other two parameters m and n. Okay, so we need to give the values m and n too. Okay, so we need to define m as any number as 1 and n is another number, 0.5 maybe. So here, why I'm doing this? Okay, so for the z data ij, for example, if I type z data like 5, 6, so that means I'm taking the 5th row and the 6th column of the z data, which will give you the value of 0. Okay, so here I am going to change this 0 into the value that we get from the function f sign. So if I try to input the f sign over here, and here there are 4 arguments in f sign, and if I simply put any random 4 number into here, it will give you some value of the function. Okay, but here these values, so 3 and 4, the first 2 arguments will come from the range that we have created. So this should be the y data. So the first one should be one number from the x data, and the other one should be another number from the y data. And m and n, it should be the parameters that we do in the function. Okay, so here we should finish assigning the values into the set data. So if you try to run this program again and then output the set data, you should have the array that is not 0 anymore, but it is full of numbers. Okay, and then to plot the 2D, we have a spatial command for you. Okay, so to plot a 2D graph. Okay, so we are using PLT again. So if you remember, PLT is the name that we define to call this library, the plotting library. So in the plotting library, I use the command called imshow, image show maybe, and then we input a 2D array into here is the set data, and then another command cmap, it is for the color map. Okay, so for the reference, you could serve the Google for this. Okay, so you can type the pyplot imshow. Okay, and here is a very good online manual for this. So it is the page from the matplotlib. Okay, and it is going to show all the options of these commands, but here I am going to use just some of the simple commands, some of the simple arguments. So I input the set data. I use the color map. Okay, so the color map here, you can import from some. I get this from some example. I using the jet color map. So it is a type of a color map. Okay, so yeah, for more details, you should visit. Yeah, please do visit this page for more detail. Okay, and then I will set the interpolation into nearest. And then after that, I will do the plt.show. And then when I run this program, okay, it will give you exactly the color map. So if I don't use the interpolation, what will happen? So if I don't use the interpolation, my graph is gonna look a little bit different. But if I and then you can also change the type of the color map. I will just pick one of these at random. Okay, bone. Okay. So the color got changed a little bit. This doesn't look very nice. I'll just go back to use jet. Okay. And then you can try to set up some new parameters. You can change the value of m. You can just having a play with this. Like if I do m equals to 2, the number of loops you got here has changed a little bit. I do like yeah, if I do like 1.5 here, yeah, here's what you get. Okay, so this is just like the sine wave in 2 dimensions. Yeah. Okay, so thank you very much for this. Thank you. Yeah,